Okay, my friends, you are in Roger's house today. We're talking about Veritasium, 11 million subscribers, talking about the big misconception about electricity. Well, I'm going to tell you something. I feel that I have about as much to say about electricity as anybody that's walking around because I've been doing this for 50 years and I understand that the electric particle itself, which is the electron, is not just a negative particle. It is a dipole. Okay, my wonderful friends, this is something that just came out from Veritasium. I very, very rarely disagree with what they say. However, this is my field, and I think I can present evidence to at least draw into question what his assessment of the flow of electricity is. Now, what he's talking about is the big misconception about electricity. Let me just break it down for you very quickly. Normally everybody thinks electrons just flow through a wire like liquid, and they're the electrons. Now, he's saying no, it's on the outside of the wire. It's the field that really is the carrier of the energy. That's how I take it. Now, I could be wrong. Watch it and see what you think. Okay, this is going to get extremely geeky, so get the geekiest geeks that you know, because I am going to explain to you that electrons are not negative particles, they are dipoles, and they have a dark side, and that dark side is dark matter. I'll explain it, I'll show it, we've seen it. I knew about this 50 years ago. These are papers from 50 years ago when I was in college. I said there was two types of intermolecular forces, but they're dipole-dipole interactions. And transfer of energy from light is to atomic vapor, which is obvious. Back then there was no solar panels or anything, but right now light hits it, it turns it into atomic particles, atomic electrons that flow through wires. Now, we're going to talk about Veritasium claim that it's not flowing through the wires. Well, we're going to discuss it. There's a little bit of a conflict there, yes, absolutely. But Rutherford's atom was wrong. and I mean, I did this a lot. I would love to interact with anyone. And my final paper was where I said there was nothing but dipoles. And that pushed me right out of the physics. After that, it was all over. Because you can't fight authority, because authority always wins. Well, right now, I have the authority to claim that electrons are made of what they call a muon, and I call that additionally gravity and dark matter, attached to a bright, brilliant, glowy particle, which is the electron. And back to back, two electrons make a photon. I will show these, and those photons have a large magnetic field around them. So the field causes a wave, but it is a particle. And a particle is made of two electrons. Protons are the smallest of the atomic nucleuses. And they are like this, not like this. Not like one big proton. They are 1,839 electrons. Each one of those is an electron. And that is what a proton is made of. And at that number, they become stable. They have what they call a resonant, shaky, vibrational, and they lock in at that number. That's a proton. Never get these near kids or animals. It will kill them. These are absolutely deadly to kids and animals. Don't get them around them. Now that I just showed you was nuclear fission. You break that? That's nuclear fission. Boom, nuclear fusion. Now we are working with this. We're working with this. All right, we're working with this range, not the protons like they are at CERN. So what I am about to show you is the interaction of the smallest bits of matter that exist, which is electrons, and dark matter muons. Okay, this is, I believe his name is Derek Mueller, absolutely fabulous. Again, it's Veritasium, 11 million subscribers, and he's always on the money. And I was with him 100% on the last one he did. Well, not the last one, but one recently where a guy bet him $10,000 about a car being able to accelerate. Anyway, it's a long story, but he won, and it was pretty obvious he was correct. But academics, when they have a point of view, I was surprised that they pushed it that far, because I've never had anybody confront me. Of course, I have, and he had evidence to prove what he was showing too. They just couldn't accept it. And he won the $10,000. Now, and I guess he's going to give it to charity. Fabulous, absolutely fabulous. And I really applaud this guy, because he stands up for one way or the other, whatever he thinks. Now, in this particular case, I'm not with him on it, and I think I can show that it is literally push to shove of the electrons, but it is fields as well, yes, and fields will follow. However, you want to suppress those fields, and we're going to suppress them with shielding. All right, and I'm going to explain to you the whole thing, but let him explain to how he thinks electricity works. And so, Derek, here you go, brother. And I'd love to discuss it with you, because until you understand electron flood theory, you're never going to really understand how electricity works, because an electron is a black and white ball, and that black ball just follows the white one, and the white one pushes and shoves. And I can show that in extreme detail, which I probably already did or will very soon.
Its electric field extends through the circuit at the speed of light. This electric field pushes electrons around so they accumulate on some of the surfaces of the conductors, making them negatively charged, and are depleted elsewhere, leaving their surfaces positively charged. These surface charges create a small electric field inside the wires, causing electrons to drift preferentially in one direction. Note that this drift velocity is extremely slow, around 1/10 of a millimeter per second.
Now, I'm not going to disagree with that, because what happens is it's pushed to shove back, and it's bouncing, basically. Now, that's DC. Is it pushing and it's shoving back? They're pushing, shoving, pushing, push, but they do drift. I agree with that 100%. Alternating current, totally different. They don't drift anywhere. They just go back and forth and slap that one, slap this one. And when they do that, it's like vibrating like crazy. That's why AC current is extremely powerful. And it can travel long distances and all that. And it's dependent upon how big the conductor is and how much voltage you apply. You can do tons of current you can flow, and it's very deadly. AC is a very, very deadly form of electricity. All right, just to back that up, AC current is said to be more dangerous than DC, and they're talking about the root mean squared value of the alternating current is much more than its original value. That's correct. Slap, bang, blah, 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 it's like vibrating between two things that keep continuously banging it back and forth. So that's what creates the heat and the light and all that, makes things glow. In CMOS, it does the same thing. It's shaking the molecules that are in there, and that forces the push to shove of these magnetic fields. Now, I'm going to let him explain, and then I'll try to explain what electron flood theory shows. All right, like I said, I'm sort of a material guy. I'm going to show you what's going on here. He's saying the electricity is flowing this way, from negative to the positive. I'm okay with that. Now watch. If I go from here to the positive, see on the voltmeter over there, 1.5363735.6, it floats right in that area. And that is the potential energy to push. Now, it depends on how much resistance I have. Like, these are the old style resistors they used to make, and you put them in circuits, and they would limit the amount of electricity, because they would say, no, you only so much you can come by here. Now, if it's a dead short from here to here, that wire will literally burn up, because all of the electrons that want to go there and normally would be pushed back by the device that they're powering, a motor or a light or whatever it is. That is the limiting factor. And there is very few electrons flow. I mean, take a look at what you got here. You know how long these things last and make lights burn for a very long time. For what you have these little tiny batteries. Now, let's continue on to see what he has to say. But we just saw electricity from, just basically what he's saying. I don't have any problem with that right now. Let's see what he has to say. Now, again, we're going to look at a lot of things. We're going to see how motors work and why do they generate electricity. Because a motor, it makes electricity when you spin it backward, or when you spin it by hand. That's a generator. When you put electricity into it, it's a motor. And it happens because of magnets that surround coils of wire. And as the coils spin in there, they force electrons to flow out. We will look at that, and we'll hook it up to the meter and see it actually happening and go positive and negative, depends on which direction you're going in. This is not really hard to understand, and we'll understand, this is what they call coax cable. I used to do this and run, video cables and all that, and that's the video signal feed inside, insulated from all the rest of the world by this braided copper. Now, why is it braided? And why is it copper? And what does that do? Well, before we continue on with Derek's presentation, I want to show you what copper does, because that is the key to all of these fields, basically. Well, it's not the key to it, but it certainly demonstrates it much more effectively than anything else, as you will see. All right, before we get any further, I just want to be absolutely certain that you understand that light is dipoles. Light is photons, and they are made of two back-to-back dipoles, which we always consider were electrons. But we always only could see the white part. Nobody's ever seen the black part attached to it. And that's what the muon are trying to find. Well, there it is. And here it is right here, those black balls. The white ones are the electrons. Cornell listed this as the 2p2h particles, which are photons, and then they lost track of it. They were neutrinos. That was back in 2013. And we continued on. I could tell you right now, those are neutrinos back to back, muon neutrino, electron neutrino. Same thing here, but back to back. They're dipoles. They're bar magnets, basically. When they hit our venturi, which is such a restriction, the black cannot compress and the white can. And the white squeezes through there and the blacks bubble away and stay exactly like they are and exactly what CERN wants to see. The muons do not change. The electrons turn into showers. They have huge fields around them. They create waves as they go through the air, as you will see. And when they compress at the venturi, they literally separate the particles. All right, so you saw the particles right here. Now let's see how they got to be like this and then how they got to be separated. Well, the way they got to be like this is it started with a pulsed red laser, just like that. Now, you see these fields? There's a particle, which I just showed you, is in each one of these fields, there's particles. And when they come through, all the other particles that exist in the air get glowy because they're being forced to concuss as well. Anytime you have a push to a shove, you get a glow. The intensity of the glow is energy. Well, what happened here? That same wave, we energized it, literally energized the hell out of it. And it caused the particle, which I showed you, that little four-banger, and now it's concussing on top of itself. It has nowhere to go, and it's being tried to force its way into this venturi. And it can't get in there. The fields are huge. The fields are gigantic. Gigantic fields. The particle's tiny, as I showed you. And all of these are tiny little particles that are glowing because of this reverse concussion at the venturi. This is literally plasma. Think of the increase in energy from where it was here to what it is there. And that was no additional requirement of energy. All it is a venturi. Now, it again created the particle, which we saw, which is the 2p2h particle, the two holes and the two glowy particles. And we saw this on one event, which was very strange. Blue, you can see here, spins, and it was expanded there, concussing up here, so it's literally slowing down, and this is literally accelerating. So light is not a stagnant, one-shot deal. And then when it hit the venturi, here's what happened to it. It split exactly what CERN wants to see. And here is the split. That was the black ball, this was the white ball. When they hit here, the black ball continue on. You see it? It doesn't go through with the white. The white turns into a shower. The black ones just can't get through. And it's because of the design of the venturi. I'll speak to someone if someone wants to speak, but I haven't found that to be the case. Now, I'm saying we can see muons, and I'm saying that's dark matter, because all it wants to do is attract back. And this is only a single slit, so the venturi, what do you call it, the interference patterns are not flappy waves. It's because the light is spinning. Look at the increase in energy here. It's absolutely staggering. And the backflow, you see this coming? This is coming backwards. Originally we sent the light this way. All of this is what they call reverse EMF, reverse electromagnetic forces, pushing backwards. And all of these little particles are glowing because they are being impacted by the reverse EMF as well. And these patterns of separation are from the spinning. Sometimes it spins that way, sometimes it spins this way. And they don't want to be next to each other, so they separate each other. And here is that spinning pattern, if I can find it amongst all, there it is right there. And again, this is all Rod Warren did all of these shots with just a cheap, simple pulse red laser spinning. Obviously it's spinning in a circle there. It doesn't spin by itself. The crystal radiates out and the particle spins, and it turns into like a drill bit looking thing as it spins. So, and that's single slit once again, and they were all divided up. Stay away from me, you stay away from me, you stay away from me, you stay away from me, and then eventually they bleed back into the rest of the universe and they become electric particles basically. And the green is identical to the red. And look at this now. Well, it's not this one. Wait did I show you this? I could show you, as I did a second ago, that we get these black balls all over. Right? You see them all over, those black balls? Completely separate, absolutely flawless to what CERN wants to see. And I'm thinking to myself, geez, I don't think I see these in the green ones like this. And I really don't. However, not like this. This is absolutely unbelievable. He had this tuned so perfectly that it completely disassociated the black and completely let the white go through. That is just stunning engineering, to be perfectly honest with you. And to be honest with you, it was just luck more than anything else. All right, you're going to have a hard time believing this, but this is the tools of the trade right here. A regular smartphone that goes back to this time frame, 2014, I believe, was when Rod got this. I got the same one, and the Bosch GLM-15 laser, the same laser he used. To do all this stuff that I showed you, that is it right there. And a couple of nails right next to each other, and then aligning the laser back and forth and creating all these fabulous shots using this to pick up the pictures. And this is what they did. They used smartphones as cosmic ray detectors. This is not something I did. It says it uses the same principles of very large experiments. It says it harnessed the detection cosmic rays in much the same way as high-end multi-million-dollar observatories. The cosmic rays are these high-end subatomic particles. All right, and that's what we're seeing. You can see them. The only ones that you see are the ones that are extremely high energy. So I decided I go back and look, and sure enough, look, there's the black particles. Now, it appears there may be a distance coming out here where there is no black, but I don't see any black coming back here at all. I think this is a step back. In other words, there's two pins here creating this slit. And if they're not perfectly aligned side to side, one of them step back behind the other so that there's like a bang, a ricochet. I think that's what might be happening. This lets the black ones filter through this way because it's a bigger slit coming this way, and this is a ricochet back off this way, something like that. I think that's what it is. There would be a pin here that was just stepped back a hair, and this one was just right exactly next to it, but a hair in front, so that it would slam back here and ricochet off this way, and some of it would ricochet out this way. That's the only thing I can take from this, but I can see all the black balls. You see them? Let me come in there close. You see it? They're all over. I didn't realize that. I never looked. I was just sort of glanced at it and let it go. They're everywhere. See them? They want to come back to those white particles, and they will, and they are. As you get way out there, they're back together. Now, on this other side, there's none at all. There's zero. And the green is extremely powerful compared to the red. I have shots showing the green and red together at the same time. But anyway, this is what I'm talking to you about, is when this thing hit here, these particles, the black and white ones together, and these were what we always considered were electrons, and these two electrons together are what we consider a photon. And we just divided them. We broke the black from the white. That's fission. And then they come back together out here. Let's come back to fusion. I don't see how you can take it in any other way. And I think it's just a simple matter of engineering a venturi like Rod did, and we could harvest free energy. And I mean literally way over free. Because of, where is it? This here. We get the laser shooting those pulses out. We crush them. No extra energy required. Strictly an engineering device. Very, very simple. And free. And then a harvester back here to where it hits. And we can collect this energy before it reattaches. Run it through our device and then let it reattach over there somewhere. And we harvest all this energy. And we use a little bit of it back to keep the laser going. All the rest we do anything we want with. And that's because we've got their photons, muons, and electrons. So I think this could use a little quick look at. Derek, I'd love to talk to you about it, brother. I guess it's best I just present my evidence first. These are the green photons, identical to the red ones, but they're the same particles, only they're spinning much faster. And I can prove all of the things I'm saying. And here's what they look like real close up. Now, that is just getting ready to compress. That's why you see these little white tabs coming. And it depends on which direction it's going, how puffed up it will get. And that I can also prove. So let's go into looking at that. This is what those particles look like. Okay? There it is right there. Well, you look at it and you say, well, it's a black and a white ball, black and a white ball. Well, however, you look at it here in its energetic values. This one is coming this way, and you can see what it's doing. It's concussing with the particles that are in the air. Those are little electrons that are all attached to the gas molecules that thing is banging into. That makes it glow, and you can see this one is smaller than that one. That makes this effect. Hold on, let me see if I can find this effect. Normally, if they were just sitting around, they would be laying around like this. They both sort of probably have the same value. I don't know. But I can tell you one thing, when they're coming through the air like this, the one that's leading, which happens at this point to be the glowy particle at the bottom, and soon it will be the one at the top, because this will overcharge and flip. Then that one will flip to the front and it will charge up, just like that one's doing now. Now, so what do we have here? We literally have this. This can squish down and get through the venturi. This can't. They don't do anything. They don't change whatsoever. They dip, 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 case closed. All I want to do is be next to a white one. That's all I want in life. All right? And the white ones can glow and bang and do everything else. This just wants it to go along for the ride. That is basically what you're looking at right there. And that is a photon. And that is the particle that we have always considered to be the electron. And they are attached back to the and when these photons hit solar panels, they turn into electricity. So it's the atomic vapor. I've said that for 50 years. And this is the proof of it. Light is atomic vapor. It is particles. Those particles create these enormous waves. All right, where is it? Red, somewhere around here. Single, there we go. Those particles are tiny, absolutely tiny, 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 tiny little particles. However, their fields are huge as they are forced to go forward. And they're push, 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 push. Everybody's pushing. And a lot of this interaction is because of the pulsations of the light. It's not just light, the laser. It's the pulsation of the light causing those particles not to be able to escape. It's going bam, 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 bam. And the big ones are slamming along with the white ones, and they're just squirting the white ones through. Exactly what CERN and Fermilab want to see. Now, and I also can claim that these are literally electrons back to back, which created the photons, well, create the neutrino and muon and electron neutrino, which is nothing more than what we would always have called an electron. It's exactly what it is. However, they can split. I would have never expected that. I got to be honest with you. This blew me right out of the water. And now I can see that we can split them in the green, the red, I'm sure in the blue. And they are all different energy intensities. And they will have different effects on different biological systems as well. If we can interact and break these particles apart at certain energy levels, they will create interactions with molecules that could be biological molecules to heal them or break them. I don't know. There's a million things you could do with this. Once you regulated the speed at which the spin was. Let me show you something. All right, just so you can see, this is the red and the green, the same time through the same slit, one above the other. The green is so powerful that it just pushed the red away and actually created vortexes of spinning particles. And the green just pushed it away, and then it reconcussed out here. The green is very energetic compared to the red. The red just stops. And again, it was pushed away. There's a couple of little tiny red particles up there. And of course, they have the same architectures of blocky little spots. Rod's shots were just stunning. This was Fabien Boulay that did this. I believe he's over in France. And he enhanced some of the pictures. Absolutely fabulous. Fabulous job. Speaking of interesting and fabulous work, this is Rod Warren's nephew, Dylan Carpenter. And he just sent these to me out of the blue. Somehow he's got some field effect app. I'm not sure what I just got these a short while ago. I'm so overwhelmed with things now, I don't have a lot of time to investigate it. But I can tell you right now, everything he sent me shows that all of these energetic things that are in space are dipoles. Now that's a moon, and even that's a dipole. It's not white and black like the really high energy particles. It's blue and yellow, which is also a dipole. That's at two different edges of the spectrum. Look at that. He sent me, and they were all, you can see dipoles everywhere. See that? The black and white are dipoles. You can actually see the semiconductor silicates in the phone, because this was just taken on a smartphone, and all of the stuff that we've been doing is on a smartphone, and it works exactly the same as what they have at CERN. They admit it. You see, they're all dipoles. See these things? I don't know what to think. I got to be perfectly honest with you. But I can tell you what, those are dipoles. And those are the energetic fields that they always have little doodles showing the dipoles. Well, these are entangled dipole fields of very, very, very exotic particles. So I just want you to have an understanding that, we got a lot of research on this. And if the particles are dipoles, which they most certainly are, I mean, I've shown you that, and when they're in space, they exhibit the dipole nature in an unbelievable way, especially the Russians when they did this plasma in space. They created a black hole. They literally created a black hole in space. And the only reason they could create it was because they had a box around the particles. And the box created its own magnetic field that forced to create the black hole on its own, surrounded by the white particles. I showed that. I'll probably show it to you again. Who knows? All right, now this is so cool. Look at this now. This is the Russians in space. And here they have a vacuum chamber. Okay, so here's the outline of the vacuum chamber. Inside is a total vacuum. There was no particles in here whatsoever until they let these charged particles, which are the little glowy bits, they let them in and they formed this black hole, and they freaked out. Now, don't forget, you have a chamber. Well, the chamber is made out of electrons too. And electrons always want to be away from each other, so it'll be 100% coated with electrons. They will be pushing electrons away from the surface here. The electrons push these charged electrons away, so it's push to shove. That's why they glow. And then they all try to get away, and the dark matter I showed can be separated, and sure enough, it separates into the middle, and they will collect around a density around here. They're all trying to get away from each other, and it's forcing the dark matter to congeal in the center. Watch what happens. And they freaked out. One of the guys on Earth went, well, listen. Anyway, it says during the experiment they contacted the guys on Earth. But watch it go pulse, 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 pulse. This was Max Planck. The Russians were working with Max Planck, and they looked at it. They freaked out. But see it pulse. He locked himself in his office for 3 weeks. But what was happening there, if you look at it and think about this carefully, I'm going to turn this down so that it goes down to 25%. Let's watch how this works. Let's get back to the beginning of the black hole. Here it goes. Watch it pulsate, and it's trying to force those electrons in. They force their black matter to get away, and they want to get away from each other, so they're really trying to, and it ends up globbing in the center. Here it goes. See it? Boom, 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 boom. Watch it. See it? Pulsing. And that is just as black can get. There is no whiteness coming through there whatsoever. And that's the nature of a black hole. It doesn't absorb, it doesn't emit, it doesn't reflect. Not a single bit of whiteness is coming out of there. That is a black hole. And they were the first to do it. This is back in 2012. I salute you, my Russian friends. Okay, I tend to get a little lost in these things, but this is a deep subject, and I would love to correspond with Derek about this. Now, here he goes back again, and let's hear what Derek has to say. So he's saying that the molecules of the electrons barely move.
But this is current. Well, conventional current is defined to flow opposite the motion of electrons, but this is what's making it happen. The charge on the surfaces of the conductors also creates an electric field outside the wires, and the current inside the wires creates a magnetic field outside the wires. So now there is a combination of electric and magnetic fields in the space around this circuit. So according to Poynting's theory, energy should be flowing, and we can work out the direction of this energy flow using the right-hand rule. Around the battery, for example, the electric field is down and the magnetic field is into the screen, so you find the energy flux is to the right, away from the battery. In fact, all around the battery you'll find the energy is radially outwards. Energy is going out through the sides of the battery into the fields.
I want to make a statement. I believe that what he is referring to is the spin. Hold on. Let me find my spinner. Alright, I think I showed before, but if I haven't, this is what electricity does, basically. It spins around in a circle like this as it goes forward. And the electrons cascade off other electrons that are around them, and it forces them to spin into a spiral as they go forward. And the right-hand rule is where they throw their electrons out into fields. If it spun backwards, and I think we have one that did spin backwards, it would pull its fields into itself, and that's exactly what we saw. Very strange. Now, he says these fields are the right-hand rule. I agree with that. They spin this direction if the electrons are flowing in that direction, if the electricity towards ground is that way. So, that's what he's saying. I agree with that so far.
Along the wires, again you can use the right-hand rule to find the energy is flowing to the right. This is true for the fields along the top wire and the bottom wire. But at the filament, the pointing vector is directed in toward the light bulb.
Alright, this is a restriction. The reason is, anytime you have any energy being used, it's a restriction. It's like resistance, like a resistor put in a wire. And sometimes they glow, sometimes it's a motor, sometimes it's a light, sometimes it's a, whatever a heating element, a burner plate, whatever it is. It's using that electron as a resistance to push other electrons to make them force heat out. And heat is nothing more than excessive electrons. And every time you have excessive electrons in a confined space, it creates heat. As they dissipate out, the heat dissipates. But when they are just electrons and they are stuck together like this, that's okay. But once they explode and they're all over, and this one creates a field like this, and this one creates a field like this, and everything is trying to get back together, that's when you have the energetic value, and then that's when you have work being done. Okay, we're going to go into copper in a second here, because copper has a very, very unique signature. And I have a good friend who makes copper jewelry that he claims can do things to your body, and I can see that there is a possibility for that. Now, why am I talking about copper being so reactive and so important? Well, copper, we use it in wires. This is what they call coax. This is the power, and that's the positive and negative that powers a device, and this was for a camera. Now that wire there picked up the video signal from the camera back to the processor, and you had to have these braided shielded cables. And you say, well, why would you have that? Well, let me show you what copper does if it's in the correct configuration. And when we're working with this kind of a signal that can pulsate this size of a wire, you need a certain type of a braid, and that's it. Let me show you. Okay, now watch this. This is on, I believe it's Nighthawk. Hold on a second. Nighthawk and light. And this is copper's surprising reaction to strong magnets. Now, this is a heavy-duty magnet. Similar to this type of style of magnet. He's going to drop it between two heavy-duty copper plates, and that's the key. You have to have a density of copper to create this huge cloud of electrons. Watch what happens. All magnets create electrons on their surface in copious amounts. Watch. You see the white around it? Those are the electrons. The black is the dark matter goes to the center of all magnets. Here's another magnet. Watch. You see it? The dark goes to the center. And that's from a motor. That's the kind of a magnet that runs a motor. This is another magnet. It's just a square magnet. Same thing though. You see it? All of the electrons end up getting to the outside surface, just like that magnet. Now watch what happens when that thing falls through. It just like falling through molasses. I know, watch.
There are a few other practical applications for this sort of motion damping. High-speed trains and even some roller coasters use a magnetic braking system set up in a way very similar to this, with powerful...
All right, think of what's going on. What's he doing? He's dragging it through a soup. He's dragging it through almost like it's in water. Well, what does it consist of? Why is it hitting? What is it hitting? Well, we know electrons push and shove other electrons. Literally, this is a cloud of electrons. Now, it is not, there's no coating around this so that it bleeds into the air. Now, I don't know if you had, insulation over the top of this, which it would dampen this effect much. I don't know. But I don't think I've seen them doing it that way. I'd like to see it. Would a insulator on top of here, just regular like plastic, coating, which you see on all the wires, maybe an 1/8 of an inch thick or something, would that stop this effect?
Powerful magnets, usually electromagnets, elevated above a conductive surface. The magnets slow the vehicle down quickly without any surface-to-surface friction that causes damage in conventional braking systems between brake pads and rotors. My favorite tabletop demonstration of magnetic braking is to swing a magnet toward a chunk of copper like a wrecking ball. The magnet loses all of its momentum at the very last moment.
Watch this. Hold on a second. Okay, I think you've seen this before. The pulse red laser, not accelerated, accelerating, exploding. When it comes out the other side, there's a big white area, and then the Higgs fields appear. The Higgs fields appear right here. And so here we are looking into the venturi this way. Swish. And right there is where these Higgs fields smash in and start to reappear. Now, there was one we had where the Higgs field, hold on. These are all the Higgs fields again. We're looking into the venturi. They're coming at us. And then they start to collide and create these fields. They're spinning with the right-hand rule. Okay, they're coming at us with the right-hand rule. This one is coming at us, but it's going in the reverse direction, the left hand. In my mind, I could be totally wrong, but I believe what happens is it pulls its field into itself, and these splay the field out and throw it out. This one pulls it back in as it comes forward. Now, if that's right, I don't know, but I can show you what happened, I think, from this particular particle. I have to be perfectly honest with you. I don't know for certain, but I think this is that same particle. Now, could be wrong. This was the end result. Regardless if it was or it wasn't, this is something very, very, very unusual. I had never seen this before. Or that other white particle, I had also never seen that. But this appears to be transitioning into a Higgs field, a weak Higgs field. I don't know. I have no idea. That's something I've never seen before, so I'm not going to speculate, but it's not normal. All right, and this has gotten very, very long. I'm sorry, but the reason this copper braiding is on here is to shield all the electrons from invading that copper core to destroy the signal of the video. You don't need them around wires that are just generating electricity or sending out electricity. This is a whole different issue. That wire there has a very specific flow of electrons, push to shove, that has to not be affected by anybody else. And that is what keeps this out, just as I showed you how it keeps out the magnet from hitting this. And it's because of the braiding. And I think I talked about Ra Castellato. He knows how this stuff works, and he makes jewelry and all kinds of stuff. I'm going to leave it at this for now. But if anybody knows Derek at Veritasium, or if Derek, you happen to see this, my friend, I would love to discuss this with you. I think we can create free energy. I have not got the capabilities to do it, but I know you are very, very capable. And I admire that, my friend, and I would certainly love to prevail upon you to contact me. All right? Thank you. I love you all.